Welcome back to Red Alt Key, your go-to channel for all things IT and technology. I'm Leslie and today we're diving into Module 6, Container Networking and Storage. In this module, we'll explore the concept of network segregation for containers and delve into container storage. Let's get started. Imagine you're running multiple containers with different applications or services. Network segregation isolates these containers into separate communication environments. This isolation enhances security, prevents interference, and allows controlled connectivity. We're going to create two separate networks, namely Network 1 and Network 2. Network, create, Network 1, press enter, rewrite the same command and change the 1 to a 2. So if we run docker network ls, we see that network 1 and network 2 have been created as bridge networks. To verify network segregation, we can easily check a container's IP address. So what we're going to do is create two separate containers. The first container is going to be tied to network 1 and the second container is going to be tied to network 2. -d network 1 and the name of the container 1, and the image that is using, I am going to use EasyBox, and I'll set sleep 3600 so that it doesn't execute and stop immediately afterwards. Press enter, docker ps is running, rewrite previous command and change the network name from 1 to 2 and change the container name from 1 to 2. So this time we're creating a second container, container number 2, and it's tied to network number 2. Press enter and docker ps. We now have two containers in two separate networks. To ensure that these containers belong to their respective networks, the segregation is tying the containers to different networks ensures that the containers belong to their respective networks. This segregation is crucial for controlled communication. So we're going to verify this network segregation and we will use this super long command that I am going to copy and paste. Copy, clear screen, paste, and I am going to remove that space and type in the name of the container. In this case, it's container 1. Press enter. The IP address for container 1 is 172.21.0.2. We will rerun the same command, however, for container 2 this time. The IP address is 172.22.0.2. So the fact that one is at 172.21 and the other is at 172.22 implies the connectivity to different networks. So what I'll do is go back here and rerun the docker run command, and then I'll create a third container. It's going to be container number 3 and I'll leave it in network 2. Press enter. There it is. Let us go back and verify the network connectivity. Container number 1, 172.21.0.2. Container number 2, 172.22.0.2. and container number 3, 172.22.0.3. As you can see, container number 2 and container number 3 are in the same network. Shifting gears, let us explore container storage. Container storage operates in layers. The file system consists of multiple read-only layers and a single writable layer. This efficient design enables fast image creation and container startup. What about data persistence? We use data volumes to persist data outside a container's writable layer. This ensures data survives container deletion and allows sharing data between containers. Let us explore some storage commands. We will create a new container and we will call it cool volume. Docker volume create cool and then we'll run docker volume ls. Cool volume is the third from the bottom, right there. Now what we'll do now is create a new Docker image or new Docker container, and we're going to mount it to that same volume, my volume. Docker run -d -p 8080 80 name my test container, and then we'll map it to volume my volume. Internally we'll map it to the folder, not user, HTML, and we'll use the image Nginx latest, download it, docker ps, it is running on port 8080, and then we're not so much concerned about running this container right now. However, we will run the docker inspect command, test container, and then we'll scroll all the way up close to where the command is that we ran, and then scroll a little bit until we get to this section that shows the container name, and down here under host config binds, you see my volume has been mapped to the internal path on the container, which is user share nginx html. So what this means is, so we're going to run docker exec to view the file system, which is docker exec -it my test container, and bash. We are now in the container, so we go to user share nginx html. So this folder is running inside our volume. So this path is running inside the my volume volume, or this path is running inside the volume called my volume. Let us exit from this container. That concludes module 6. We've learned how to segregate container networks for enhanced security and explored container storage fundamentals. In the next module, we'll dive into Docker Compose. If you found this module helpful, please give us a thumbs up and don't forget to subscribe for more Docker knowledge. Stay tuned for module 7 and happy containerizing. Bye.